All right, there's some questions on the homework here. I'm sort of going to go through the questions that were there. First question comes up from question number 4. Is this process right here? Is how do we graph these things and what does it mean? Problem number 4. Remember, the whole point of section 8.1 is to find that particular point on the graph in which there's the intersection point between the two. So x minus 1 is equal to negative 5. Better graph that guy. And x plus 1 equals 13. So notice the graph is kind of large for that here. So what's the work behind it first of all? That's what we're going to figure out first, and then we'll go from there. So let me switch to a different screen just so we can do the work here. And so x minus 5 is equal, so x minus y is equal to, I'm going to be switching between two screens here. X minus y is equal to negative 5. X plus y 13, okay, and x plus y is equal to 13. Now there's two different ways to graph these, just depending what you want to do. There's the, I'm going to show you both methods here. There's the intercept method. Intercept method, all it is you plug in a 0 for the x value, and then you just figure out what the y value would be. In this case, it's just y equals 5. Cool. Then what you do is you plug a 0 in for the y value. This becomes a y value. Notice what happens is you got your answer here. Again, this is just a quick way to get answers to 2 points to get a line going. All right, the other way is called the slope-intercept method, and this one you solve for y. I think you guys are familiar with this as well. There it is. This is in the form of mx plus b. B is being the y-intercept. Oh, sorry, it's 13. B being the y-intercept, and the m value is technically negative 1 over 1. So let's graph these here. Let's see what we get here. Back to our problem. Enlarge the graph here. And I'm going to go a straight line. That's what I'm doing. And my coordinates are, let me go back to this guy here just to make sure, 0, 5, and negative 5, 0. There's my first line. My second equation the other way is you start off with 13, we're going to go down 1 over 1. So again, line again. Start off with 13, down 1 over 1. And there it is. We save this guy. Check answer. Voila. We go on to the next part. So now the question is it a one solution? Yes, it is one solution because they do cross. And the answer here is, and again, we're going to go to this part right here. The answer, we've got to figure out where's the answer here. Let's click on the graph itself. Correct answer, your answer, yeah, it's fine. But I got myself, looks like 4, 9 is the solution here. So 4, 9 is the answer. Let's check our answer. Let's see what we got. Perfect, excellent. We're so awesome. Okay, the next problem here that we have is graphing these guys. Notice this guy's already solved for y. Awesome, we're ready. This is my slope. This is my y-intercept, my slope. This guy's not solved for y yet, but it's so easy to do so here. So 2y, 4x, 14. Let's go with 2y is equal to 4x plus 14. Divide both sides by 2. And now I'm ready to graph. This is 2x plus 7. That's one graph. That's actually the bottom graph. The other one is this guy here. Technically that's the top graph. Top graph is right here. The bottom graph is here. But notice something interesting. Notice the fact that they have same slopes and different y-intercepts. So they cross the y-axis at a different spot, but they go up the same amount. So let's see what happens here. Let's graph the first one technically. So negative 3. Enlarge it. We're starting off at negative 3. Boom. We're going to go up 2 and 1 to the right. Okay, let's graph the other one. The other one is actually start off at 7. We're going to go up 2, 1 to the right, and I think that's it. Let's check our answer. Awesome. Now the question is what's happening here. Now, because they are parallel lines, that means there's no solution. There's never a time where this actually has a solution of a set of coordinates that fulfill both equations at the same time. So that means this is C right over here. Now, if it was one line that actually was right on top of the other line, if you had to make both lines they were right on top of each other, then that would be a dependent system. So one is the solution. We did this on the previous problem here. Problem number 4, we had one solution. That's when the lines crossed. A dependent system is when the lines are right on top of each other. An inconsistent system is when you have this situation here where the lines are parallel. Let's check our answer. Voila, we're done with that one here. 2 more to go. Number 6. So in this case here, looks like I have 3x plus y is equal to 12. That one is not solved for y. Let me go ahead and do so. Let me subtract 3x from both sides, and if you can kind of see what's going to happen here, the top equation, when you subtract 3x from both sides, here's a plus, yeah, it's plus 12. When you do this, notice what you're going to get when you start solving the top equation. You're going to get this guy, which looks exactly the same as that bottom equation already. What does that mean? Well, that means you're going to draw the exact same line. So as we draw this one from the other place, let's say it looks like we're starting off at 12, going down 1, 2, 3, going off 1 to the right. That's one line. The next line does the exact same thing. Starts off at 12, goes down 3, and then really what you have is you have 2 lines right on top of each other. So let's check. Yes. Okay, what does that mean? That means there is one solution. No way. There's a whole bunch of solutions. So anything that's on the first line is also on the second line. So as we say, there's an infinite number of solutions. No solution again would be if there were parallel lines. They don't ever cross. They don't ever be the answer. Okay, so this one here. Then they actually want to say, what's the expression for the answer? So if you plug in an x, remember with coordinates, it's always x comma y. So they want to know the relationship. So notice on the second equation, the relationship between x and y is plug in x, and you get this for y. Okay, if that is the case, notice what we did is on this one, when we solved it, we got the same exact equation. So what they want is they want this equation right here. They want the relationship between, if you plug in x, what would y equal to? Well, it's negative 3x plus 12. That's the expression here. So negative 3x plus 12. Oh, I forgot the 3 in there. There should be 3 there. There you go. All right, let's check our answer. Let's see if we're right. We are right, of course. Okay, that's number 6. And the other question that was there is number 21. So let's jump all the way to the end. Number 21. We have the supply and demand curve here. All right, so just based upon where this, like if you have it solved for P, like the one on the videos that I gave for the class here, that one was, both of them were solved for P. This one, they're not solved for P, but they have P and X's underneath each other. So let me rewrite this problem. There it goes, 6P plus X is equal to 290. 15P minus X is equal to 550, and we have to solve these now. Notice right over here, you have variables that are opposites of each other. If you have that situation happening, this is good, because what we're going to do here is we're just going to add them up. When you add them up, the x's cancel each other out. That's what you want to do, because you want this one to be, and now I'm going to do some work here. So that's 0, that's 14, and that's going to be 5, 6, 7, 8. So divide by this, and get myself price would be, I think it'll be 40, is that right? 40. So P is for price. So in order to get the equilibrium price, now that, what is the equilibrium price? Equilibrium price is the fact that you're going to sell exactly how many you have demand for. You won't have any leftovers. You're going to get the price that gives you that here. Okay, so we got P. We got to still find X. Choose one of these equations. It doesn't matter which one you choose. And we're going to plug in what we know already. So we know that that P is 40. We plugged it in. That gives me 240 after multiplying by 6. And as we subtract 240 from both sides, we get X equals 50. All right. So what do we got here? We're going to sell 50 units if we put a price of $40. Let's see if we're good there. So what is the equilibrium point? Oh, well, go like this. Usually, see, I'm not sure about the order here, because usually P goes first. Let's see, in each given, P represents the price of dollars per unit, and X represents the number of units in the price. Okay, well, let's try this here. So let's see, with this one here, we can jump between the two here, 20 P. Let's go P first, and if not, then we'll do it the other way here. Usually it's X comma P. That's normally the way it's written, but it seems like it was probably written the other way. Let's check. Switch the value. The first part is the number of units. There it is. The second part is the dollar price. There you go. So let's go back to here. All right, the ordered pair is always X and then P. They confused me right here because I had the P first and the X. So I know I got this one right. All right. Hopefully that helps with the questions you guys may have had on these questions.